Hello friends, இந்த வீடியோவில் நம்ம பார்க்க போகிற சப்ஜெக்ட் இன்டகிரேட்டட் எலக்ட்ரானிக்ஸ். Types of counters. Counters are broadly divided into two categories: asynchronous counter, synchronous counter. Now we see the counters definition. A counter is a device which can count any particular event on the basis of how many times the particular event is occurred. In a digital logic system or computers, these counters can count and store the number of time any particular event or process have occurred, depending on a clock signal. Most common type of counter is sequential digital logic circuit with a single clock. Input and multiple outputs. The outputs represent binary or binary coded decimal numbers. Synchronous counter. A synchronous counter is the counter in which the clock input with all the flip-flops uses the same source and produces the output at the same time. It operates at the same time. It has no associated propagation delay. This is the circuit diagram of synchronous counter. In the above image, the basic synchronous counter design is shown, which is synchronous up counter. A 4-bit synchronous up counter starts to count from 0 and it increments the count upwards to 15 and then starts new counting cycle by getting reset. Its operating frequency is much higher than the same range asynchronous counter. Also, there is no propagation delay in the synchronous counter. Just because all flip-flops are counted, stage is in the parallel clock source and the clock triggers all counters at the same time. Asynchronous counter. These are the counters in which we do not use universal clock. Main clock is only applied to the first flip-flop, and then for rest of the flip-flops, the output of the previous flip-flop is taken as a clock. Asynchronous down counter. This is very similar to the up counter. For the down counter, the transition will be from low to high. Here is a circuit diagram of asynchronous counters. Here, as we can clearly see that 3 negative edge triggered flip-flops are sequentially connected, where the output of one flip-flop is provided as the input to the next. The input clock pulse is applied at the least significant or the firstmost flip-flop in the arrangement. Also, logic high signals, example 1, is provided at the J and K input terminals of the flip-flops. Therefore, toggling will be achieved at the negative transition of the applied clock input. Difference between the asynchronous counters and synchronous counters. Synchronous. In synchronous circuits, memory elements are clocked flip-flops. In synchronous circuits, the change in input signal can affect memory element upon activation of clock signals. The maximum operating speed of clock depends on time delays involved. Easier to design. Asynchronous sequential circuits. In asynchronous circuits, memory elements are either unlocked flip-flops or time delay elements. In asynchronous circuits, change in input signals can affect memory element at any instant of time. Because of absence of clock, asynchronous circuits can operate faster than synchronous circuits, more difficult to design. That's all friends. Thank you.